think the biggest difference is the agent's ability to use tools and take actions on behalf of the user. If you go to a chatbot like ChatGPT and ask it to build a Simulink model, it's going to provide you with lots of great information, but it's not going to give you that model. AI is going to amplify engineers' creativity and productivity and enable them to do much more than ever before. AI needs to be introduced more thoughtfully, and it should be introduced together with the use of deterministic tools. We've been working with a major European automotive manufacturer to help them apply agentic AI into that issue investigating workflow, and they're already seeing a 20% time saving.
All right, Tianyi, welcome to the show.
Thanks for inviting me, Joseph. Happy to join.
Thank you very much. Today we'll talk about AI agents, generative AI also in engineering, and what it means in terms of like how MathWorks thinks about generative AI and how engineers can be using generative AI and AI agents, for example, in MATLAB or Simulink. But before we get started, can you give us a short introduction to yourself? Who are you in the first place and what do you do at MathWorks?
My name is Tianyi, and I am a Generative AI Product Manager at MathWorks. And my current focus is helping engineers adopt generative AI to accelerate their engineering workflows. And I also work closely with the development teams to incorporate customers' feedback into refining and creating the roadmap for our agentic AI integrations with MATLAB and Simulink.
Interesting. So we had a lot of keywords in your introduction already: generative AI, AI agents, agentic workflows, and so on and so forth. Can we maybe get it clear once and for all? Like, what is agentic AI? What are agents? What is AI automation? Like, how do you differentiate those terms?
I think the biggest difference is the agent's ability to use tools and take actions on behalf of the user. Whereas a Gen AI chatbot or a generic AI assistant, it works more like a Q&A format, which you ask it a question and it gives you an answer. And a simple example is that if you go to a chatbot like ChatGPT and ask it to build a Simulink model, it's going to provide you with lots of great information, like give you the steps on how you can create that model on your own, but it's not going to give you that model. Whereas with an AI agent like GitHub Copilot, you can connect your AI agent to Simulink using Simulink Agentic Toolkit. And the agent will get your requirements. It will figure out what are the blocks to use. It will wire up all of the components into the model, run some simulations, and eventually gives you back the model, sometimes even with simulation results. So the defining capabilities of AI agents is really about the ability to use tools and to actually help you get things done, rather than simply giving you advice on something could be done.
I have one question, Tianyi, which is usually people would call it maybe automation back in the days because you're automating something between different tools. What makes agentic AI agentic?
I think in terms of the productivity unlocks, Gen AI can call tools. It can use different software APIs. In the case of Simulink, we provide a set of tools from the Simulink Agentic Toolkit that the agent can call. For example, for getting information from the model. So in that case, it's called a model overview or model read. So it helps agent understand what the model is doing. And we have functionalities for the agent to directly manipulate the model using tools like model edit. So these tools help the agent look into what a Simulink model is doing, how to create a Simulink model, and how to do things like running simulations. So the higher degree of automation is really enabled by this loop where the engineer works hand in hand with the AI agent, and the agent can call into different tools, use MATLAB and Simulink, and gives the user back a set of results.
You just mentioned engineers, and I think we should maybe talk about that sentence that's maybe sometimes misused, which is AI is going to replace engineers. Do you think this is the case? What do you personally think about this?
So my response is that AI is going to amplify engineers' creativity and productivity and enable them to do much more than ever before. What I'm seeing is that the AI agent is taking on the mechanical parts of the job and free engineers up to have more time to try out new ideas, to do more experiments, to explore the design space more widely, and things that that they simply didn't have time to do before. And I've talked to many engineers about this new way of working with AI agents, and they're really excited about it because it's helping them focus on the truly creative parts of their job, like
Mhm.
deciding what to build, how to verify something truly works, and what is good enough to ship.
I'm wondering, you talked about this amplification factor of AI, which I would agree with, but there's an upward spiral and maybe also a downward spiral. So it can amplify the good things, but also the bad things. What do we have to ensure as engineers before we even think about AI? What do we have to get right first before even thinking about implementing or adopting AI?
I think in the case of using AI, one of the biggest fallacies or misconceptions of using AI is it's an all or nothing question, right? It's either 100% AI automated or 0% AI involved. And I really think it's a when and how question. It's simply unrealistic for an engineer to, for example, one shot a moon landing system. That would be the wrong application of AI. I think engineers still need to apply AI thoughtfully to their job by picking the right use cases and focusing on automating the workflows that are largely repetitive and manual. So I think engineers are looking at their workflows and thinking about, what are the things that they can automate with AI, and what are the guardrails that they need to put in place to help the AI um, navigate the complex work that they do.
Mhm. Sometimes we mention this in one sentence, Tianyi, which you really like how you put it. You basically said like we find the tedious tasks and then we try to automate them, and if necessary, we then can just put AI on top of it. Before this podcast, I actually had a meeting with Toshi, one of your colleagues from MathWorks, and we talked about change management, how easy it actually is to think about AI and what we can do, how nice it could be, etc. Like we think in terms of what ifs, but the thing is, I think what's the hardest part is change management, like actually making people adopt AI and helping them adopt AI. So, how can we facilitate, especially for the engineering audience listening to this podcast and maybe struggling with something that they could potentially make use of, maybe MATLAB or Simulink, plus agentic AI on top of it? How can they identify, find use cases that are capable to actually use AI? And how can we make sure that their supervisor, for example, is open to adopt these ideas of AI in the first place?
Yeah, I think what's really important is to start with a small project, to start from small pieces the engineers can automate, to get initial projects started quickly. So instead of, as I mentioned before, one-shotting entire system, they should carefully manage the scope and the boundaries of the application of AI in their work. And the second advice that I have is that, in the case of engineering, um, documentation is really important. So demonstrating what are the processes, what are the tools, and what are the things that you're doing to keep the models that you build in sync with your requirements. So the idea of traceability is really important. So AI has given us tremendous benefits in terms of helping the engineer maintain the traceability between different types of engineering artifacts. And it's helping engineers generate the documentation to help them show to other teams how they have built the system.
Mhm. What do you think, Tianyi, is the most difficult part when trying to adopt AI?
I think one of the most difficult parts is about um, picking the right starting point,
Mhm.
and learning how AI works, what are the limitations of AI as you go. I think the takeaway that I have from working with some of the 10x engineers is that they don't really jump right into using AI for everything. They usually pick the
Mhm.
small part of the work and they iterate with the AI tool. And sometimes they even ask the AI to reflect its own thinking so that they can turn these learnings into AI skills that are reusable and repeatable so that they don't have to repeat their prompts over and over again the next time when the question arises. So AI
Mhm.
engineers are really, starting to develop these habits, and they're using their learning, using their firsthand experience to guide how they navigate the AI landscape.
When we talk about unlocks, Tianyi, when it comes to agents operating across, for example, MATLAB and Simulink, right? What became possible right now with agentic AI?
So something that I'm really excited about is using agents to not just vibe code purely digital artifacts like a web app or a mobile app. It's actually about helping engineers deliver engineer systems that have to be safe and reliable, that have to interact with the physical world. Things like moving a robot arm, spinning the motor inside of an electric vehicle, or just controlling, the landing and takeoff of airplanes. So what's already possible today is that the engineer can hand the agent a set of written requirements for a system to be built and ask the agent to build that initial version. So the agent can read the requirements, break it down, builds a first draft model, run some simulations, and hand these results back for the engineer to review. So this loop used to take a lot of manual steps, and now agents can do this much faster and much more efficiently with trusted engineering tools like MATLAB and Simulink. And we think that this structured process is what helps engineers stay in control and be fully informed of what the agent is doing and to steer the agent towards the right outcomes.
hmm This was the engineering side of things. When we talk about the ROI side of things, right, we have to define KPIs before we maybe start a use case. Maybe we don't. Maybe you can talk to us a little bit about that. Like, how do we define KPIs in the first place? And then what returns have you seen at Tianyi in terms of generative AI when used in engineering applications?
So one of the key stages in the development workflow where I'm seeing the biggest productivity unlock is issue resolution. So an example of that is an engineer identifies an issue in a model, and how much time does it take for the engineer to investigate into the issue, write the test to confirm that the issue exists, deliver a fix, and then finally resolve the issue. So we've been working with a major European automotive manufacturer to help them apply agentic AI into that issue investigating workflow. And they're already seeing a 20% time saving when the engineer works together with the AI agent. Um, what happens is that the agent takes on the verification as well as the issue investigation tasks while the human stays in the loop. The human reviews the AI agent's work and helps confirm that the agent is on the right trajectory. And then, so there's really a hand-in-hand process where the agent and the human work together to resolve issues much faster than ever before.
I have one maybe side question, which is if you work on revolutionary products, especially in the automotive industry, where you have to get the time to market maybe from 5 years to 3 years, which is an enormous reduction of time spent that you can spend on actually developing a new car because, well, keyword China speed. The question is, how can you actually achieve that with agentic AI? Do you have any concrete use cases in mind where we can use agentic AI with MATLAB and or Simulink, where the engineers were like, okay, we were blown away by the speed that you've achieved, but maybe you can talk about a few use cases. Obviously, if they're not under NDA, that would be
Yeah.
pretty interesting for the audience to hear about.
So there are some use cases where agentic AI can deliver very significant benefits. And one of them is helping engineers run simulations. So engineers have been using simulations to help them validate design ideas and to catch design issues early in the process rather than late so that they can avoid the costly rework uh, down the line. And the process of running simulations involves actually a lot of steps, like getting data connected to simulation outputs, configuring simulation settings, plotting and visualizing results. And we're seeing that the AI agent can help automate a lot of these manual steps, and it has significantly shortened the time that the engineer takes to go from simulation to insights. So the engineers can really focus on simulation outcomes and the analysis of these outcomes and use them to drive better decision making rather than focusing on the nitty gritty of how simulations are run or how results are plotted. Another
Mhm.
use case that I sort of mentioned before is this idea that the agent can turn a written set of requirements into a Simulink model that actually simulates. And the engineers can review the simulation results directly without having to without having to move the blocks around or without having to manually stitch together the signal lines or do the signal routing, or they don't have to script anything. So we're seeing a lot of productivity improvements when it comes to generating, creating models. And a
Mm-hmm.
third use case that I want to mention is about model refactoring. So engineers might have a lot of artifacts that they created from before, or they take over from other teams that are not really built based on the best practices. So they want to do some systematic cleanups and documentation on these legacy artifacts before they can work on new designs. So AI agent is demonstrating significant productivity improvements in terms of helping the engineer upgrade or refactor these legacy artifacts.
Mm-hmm. I have one note with regards to revolutionary product, right? I mean that these models are most likely trained on past data, I would assume, right? You can correct me if I'm wrong. The thing is, if you work on revolutionary products, how can you think outside the box if the box is literally limited? Like, is there some way how we can make the engineers even better and generate maybe new ideas, something revolutionary? Is that possible, do you think, or is it still wishful thinking?
I don't think there's an upper bound to human creativity and engineers' ability to create revolutionary and amazing products. Um, and I think it's really about combining the trusted tools like MATLAB and Simulink and the power of agentic AI and using that combination to amplify engineers' creativity. That's going to be more and more important because one of the most voiced concerns that I'm hearing from customers is that they think Gen AI can help them move a lot more faster than before. But they're also concerned that whether they're going to sacrifice on the quality of the system that they build. And
Mm-hmm.
our answer to that is they don't have to be forced into a decision or trade off between speed and quality. So MATLAB and Simulink provide them with a framework for quality and determinism. And Gen AI adds the speed on top of it to help the human engineer create much faster and have more confidence in what they've created.
Mm-hmm. To become more practical, Tianyi, I think maybe we can have like a getting started section at this point of the podcast. So when engineers would like to get started with AI, how can they get started? Because honestly, like if I go on LinkedIn, I get a little bit of AI fatigue. Everybody talks about AI, but barely anyone uses it. So maybe we can have some practical tips from your side, Tianyi, how engineers can get started when they want to play around or maybe test something with generative AI.
I would say the first advice is that always keep your eyes and ears open. Uh, uh, don't tie yourself to a fixed misconception about how AI works because these tools and techniques are changing all the time. So always look out for and try out new tools and techniques. Two is, there's a lot of overhype on what AI can do. But for engineers, it's really important to find the realistic use cases and to start from a small scoped project to apply AI rather than using AI for everything. So focusing on the right use cases is an important step. And then really use your firsthand experience with AI to guide your learning process so that you can have a better sense of what are the limitations of this technology and what are the great places that you can use this technology for. So in a sense that you are growing your capabilities to use AI as AI's capabilities grow. So you're on this learning trajectory together with the development of AI capabilities.
Mhm. How can you then unlock the adoption of AI inside of the organization? We talked about this earlier in the podcast, Yanyi, but how can we actually get started to make sure that even the decision makers inside of the company are convinced that AI is the way to go? And if it's not the way to go, also maybe convince them like maybe we should give it a try according to the crawl, walk, run approach to maybe give at least a small use case a try and then see where it's heading towards.
Yeah, so getting to my point before, right? AI adoption should not be treated as a all or nothing question, right? It should be really
Yeah.
a when and where question. So there are some engineering cases where AI needs to be introduced more thoughtfully, and it should be introduced together with the use of deterministic tools. So an example I can give you is testing. So for testing, Simulink provides a set of tools that use mathematical methods to generate tests. So when it comes to using AI for testing, the AI agents should still rely on these tools for creating test cases. What AI can automate is setting up what I call the testing infrastructure and building the scaffolding around your tests things like creating a test class or creating a test harness. Um, and it's also important to figure out where AI can be really creative in terms of solving engineering problems. So in terms of testing, it's using AI to come up with edge cases that are really hard to catch. So it's great for drafting testing strategy or a testing plan. So one, it's about combining deterministic tools with AI to make AI more effective. Two is about um, figuring out the use cases where there's a lot of manual work and a lot of repetitive work and using AI for these tasks. And three is about how AI can be used to amplify humans' creativity and productivity so that it becomes a complementary approach.
You talked about deterministic tools. AI is per definition non-deterministic. Let's say you work on a high-risk use case, right, in engineering. How can you ensure that something non-deterministic works for something high-risk deterministic? How can you combine those two?
Yeah, my answer to that is that AI still needs to rely on proven and deterministic tools like MATLAB and Simulink to help the engineer achieve the best results. For example, I can give an AI a simple task, as simple as like adding two numbers. The AI can try doing math on its own without using any tools. It's likely going to burn through a lot of tokens and it might still not get to the right results. Or it can just use a calculator to get to the right results and much more efficiently. So it's really about combining AI with tools like MATLAB and Simulink, and that is going to make the engineer's job much easier.
Mm-hmm. Is there still maybe a use case or a couple of use cases where you would advise an engineer not to use AI?
Yeah, as I mentioned before, testing is something that needs to, uh, testing is a category where AI needs to be introduced more thoughtfully. A lot of people are saying, they can use AI to write code, they can use AI to write tests for the code, but a lot of times uh, AI just does reward hacking, which means that it's going to write the tests that are going to pass based on its code that's written previously. So right now there's a lot of misconceptions about using AI as a magic wand to create both code and models and tests for verification of the system that the AI has built. But as I mentioned before, you should first start with using deterministic testing tools that generate test cases based on mathematically proved heuristics. And then you should use AI as sort of a second pair of eyes to help the engineer catch the hard to find edge cases and to make the testing more comprehensive and more robust.
Mm-hmm. When we talk about the security aspect of AI, how worried should people be about intellectual property and confidentiality? And what policy would you advise people to take on when working with AI?
So I've been working with a lot of organizations and they have slightly different policies when it comes to handling their data and their intellectual properties based on their specific organizational needs. So our approach is that we want to meet customers where they are by giving them the flexibility to bring in their own internally approved large language model infrastructure, which includes their models and their AI agents, and use these uh, to connect to Simulink and to amplify their engineering productivity.
Mm-hmm. We talked about, or you mentioned, I believe, earlier on the 10x engineer. The question is, if someone listens to this podcast and they're not a 10x engineer yet, but they want to become a 10x or maybe a 100x engineer, right? What would you advise them to do? Because I think even the founding father of OpenAI, one of the founding fathers, Andrej Karpathy, he said that even he himself is barely able to catch up with all the new changes happening in AI. So what would you advise an engineer to do? What to focus on and really become that 10x engineer that you talked about?
I would say, even though AI agents are amazing in terms of writing code, creating models, creating test plans, they still need a lot of guidance when it comes to using tools like MATLAB and Simulink. And for engineers who are in their day-to-day working on creating and verifying Simulink models, um, we've introduced for these engineers a set of tools and skills in the Simulink Agentic Toolkit. So these tools are really designed for the AI agent to effectively create, edit, and test Simulink models. And inside of this toolkit, there are also skills that encode best practices for when and how to use these tools. So best practices for model-based design. So the AI agent needs both the tools and the expertise to be proficient in Simulink and using all the products and model-based design. So the engineer, so my advice is that the engineers who's working with MATLAB and Simulink should start trying out Simulink Agentic Toolkit and combine that to use with their AI agents for their day-to-day Simulink tasks. That is going to provide a lot more unlocks in terms of improving engineers' productivity.
That's skill-wise. When you talk about the 10x engineer habits, tools, and maybe also the mindset, when we talk about the psychological aspect, what skills in that sense do engineers have to bring with, or like maybe develop?
Yeah, one of the skills is that the engineer should stay in touch with what's happening in the AI tools and AI expertise landscape. For example, listen to podcasts. I would recommend your podcast.
Thanks.
And two is about figuring out what are the realistic use cases by starting small, by picking a small piece of the project that you probably find yourself repeating every day or every week, and start building out an agentic version of it and evaluate how the AI agent is doing. And if something doesn't work, you can ask the AI agent to reflect on its thinking, and you can evolve AI agent skills by incorporating more information from interacting with the AI agent. And as I said before, you should really use your first-hand experience to guide the learning process.
Maybe one of the last questions is if you want to give the engineers out there or people who want to delve into AI agents a concrete tip on how to get started, maybe for, let's say, they want to have a project of, let's say, 7 days, 1 month, or maybe 3 months. What would you advise them to do? Because honestly, I feel like once people started to use LLMs and this whole thing has been democratized, I feel people are using AI as a hammer, but everything looks like a nail to them. So how can we make sure they pick the right use case? Would you go from the approach and say, well, look for a problem first and then develop the solution? Or would you just give them 1 or 2 or 3 concrete use cases to work on just to fiddle around with it a little bit?
Yeah, so one immediate action that any engineer watching this podcast today can get, that any engineers watching this podcast can take today is that they can pull the Simulink Agentic Toolkit off of GitHub and point your AI agent at the toolkit so that you can start experimenting with how to apply agentic AI with Simulink. So my advice again is to start with a small task, like tell the AI agent to explain a subsystem inside of the model and watch what the AI agent does. And then you can move on from that to more ambitious tasks, like changing a model to add a new subsystem that implements a specific functionality based on a set of requirements. So as you build your knowledge and understanding of how to use the toolkit over time, you can move from a task to an entire workflow that you find yourself repeating over and over again, and build the agentic version of it. And another tip is, you can always find me on LinkedIn. So I post regularly about what are the latest advances in Gen AI with Simulink and model-based design. So stay tuned about the updates from me, and just keep your eyes open on what's happening in the AI space.
I'll definitely put all the relevant links in the description. Is there anything else that I haven't asked you that should have been asked in this podcast, Tianyi, before we wrap it up?
I think there are a lot of young engineers in college who are a little anxious, and they want to seek some certainty among all of these changes that are happening in AI, and they're looking for advice. So I get this question a lot. What should a young engineers ask? what should a young engineer learn in 2026 to stay relevant in engineering and catch up with all the things that are happening in Gen AI? So my answer has stayed surprisingly consistent despite all of these changes. And my first advice is to, dive deeply into the engineering domain. So whether it's controls, whether it's signal processing or electronics. So the domain expertise will help you work more effectively with the AI agent. You can understand what the AI agent is doing. You can steer it towards better outcomes. And the second advice is, do a lot of real world projects. This is your opportunity to solve a real world problem and learn how to work effectively with other people. And also learn how to work with agents and steer the agents. Things like, how do you specify a goal? How do you write good requirements? How do you know when the agent is not producing the right outcomes? And how do you steer it towards the right trajectory?
That was a beautiful podcast, Tianyi. With that, thank you very much. And hopefully we'll have another catch up where you can maybe demonstrate in a deep dive session how these agentic systems work with MATLAB and Simulink. So thanks again, and hopefully see you in one of the next episodes.
Of course. Thank you, Joseph.